we had a couple of questions which I posed for you in class, and here are the worked examples for those. So I'm just going to tease this out now, and the idea, of course, is we have something which we need, which really is a quadratic in disguise. We're going to turn it into a quadratic in terms of x. We're going to solve for x and work out what possible values of p would make this true. So let's go ahead and do that now. So let's see if I can identify the quadratic. Well, here is a 3p, which we could just simply call x. And here's a 9p, which is really 3p squared, or 3p times 3p. So that obviously we could say is an x squared, because as we said before, because 3p, if 3p is x, then 3p times 3p is 9 to the power of p. Sorry, when I say 3p, I mean 3 to the power of p. All right, so now we can easily make this into a rather nice quadratic. We've got x squared plus 11x minus 12 equals 0. All right, so we've got factors of 12, and factors of 12, 1, 12, 2, 6, 3, 4, but only 2 of them can be added or subtracted in some sort of a way that equals 11, and that's 1 and 12. So let's have a look at the factorization. We have an x and an x. We've got a 12. We've got factors, the numbers are different. Negative means they're different. Positive here means the biggest one is positive. Looks like we can have a positive 12 and a 1. 1 times 12 is 12. So either x is going to equal 1 or x is going to equal to negative 12. Question, of course, is which one of those plays out. So we know what x is. X is 3p. So instead of saying x is 12 or negative 12, we can say x is 3p. So I could say 3 to the power of p is equal to 1, or 3 to the power of p is equal to negative 12. Well, here's the thing. There's nothing you can make p to be which would result in a negative integer here on this side. So it's not possible to have the logarithm of a negative number. So this here is simply not a solution. And we can see that straight away. But 3 to the power of p, well, anything to the power of 0 is 1. So therefore we can say 3 to the power of 0 is 1. So we're saying really p is going to equal 0. Well, let's see if that's a possible solution for this equation here. So let's go through and restate the equation. Here it is. I'll rewrite that out. So I'll say, well, 9 to the power of p plus 11 times 3 to the power of p minus 12 is equal to 0. Is that true if we make p equal 0? So that seems like a pretty simple thing to do. So let's say p equals 0. So 0 is going to go in here, and 0 is going to go in here. All right, so we're going to have 9 to the power of 0 plus 11 times 3 to the power of 0 minus 12. We really didn't need the brackets there at all, is equal to 0. So we've got 9 to the power of 0, well, that's 1, plus 3 to the power of 0 is 1, and we've got 11 times 1, which is 11. So 1 plus 11 minus 12 is equal to 0. Yes, that works because we've got 12 minus 12 is equal to 0. So therefore, quite simply, p equals, oops, I can't see that, p equals 0, as shown by here, is a solution. And that's the answer we're after.